using the electrochemical series to predict whether a redox reaction can occur or not. What we need for a redox reaction to occur is the combination of a stronger oxidizer with a stronger reducer. So if we combine them together, then we will have a spontaneous redox reaction occur. We don't know the rate. We can't predict whether it's going to be fast or not, but we can state categorically whether it will occur or not. So when I say a stronger oxidizer and a stronger reducer, what I mean is that we need to have this kind of diagonal relationship from the electrochemicals, the standard reduction potentials. So this is my stronger oxidizer reacting with my stronger reducer. Okay, and if we have this kind of diagonal relationship, then the spontaneous redox reaction will occur. That means I can look on here and just say I had copper sulfate solution and nickel metal. Well, they are in this diagonal relationship, and so if I combine them together, a spontaneous redox reaction will occur where the copper ions will be reduced to copper metal and the nickel will be oxidized to nickel ions. Okay, so that, because they are in this relationship here of the stronger oxidizer to the stronger reducer. And it doesn't matter where on the electrochemical series you are sitting, as long as they are in that relationship, then a spontaneous redox reaction will occur. For example, if I have aluminium ions, and I don't think I'll go down there actually. For example, if I have cadmium 2+ ions here, and even iron, okay, it's just the next one down. It doesn't matter, as long as it is in this diagonal relationship here, the spontaneous redox reaction will occur.
Does it have to go that way down? Can it go the other way?
It has to go that way. And so we have to be reacting the stronger oxidizer with the stronger reducer. Okay, but like I said, it could even be up here. It doesn't have to be, across the middle. It can be anywhere on here, as long as we have a stronger oxidizer reacting with a reducer that's stronger than that oxidizer. Okay, it's got more reducing ability. So, yeah, we could react our acidified permanganate here with chloride ions, and will form chlorine gas and manganese ions. Okay, as long as it's that way, and it must be that way. And I don't know if this will help you remember it, but does everyone know the hypnotoad? All hail the hypnotoad. Because we love the hypnotoad. Okay, if you love, hand on heart, we don't pledge allegiance really like the Americans do, but if we pledged allegiance or swore allegiance to the hypnotoad, then we think of our heart sort of leans slightly to the left. So you do it with your right hand. That is the correct orientation for a spontaneous redox reaction. Okay? We love, I heart redox. All hail the hypnotoad. You should be able to get it right way around.
What's hypnotoad?
Why hypnotoad?
What's a hypnotoad?
equation helps.
Is it like hypnotized toys?
This one better.
King Charles. Okay.
That's a lot of taps. It better be a flawed video.
Yeah.
And the grand prize winner, the Hypnotoad. All glory to the Hypnotoad.
Okay. Yeah, I do have a squillion tabs open.
Right.
But we do need to remember that we need to have, it's this way around, for spontaneous redox reactions to occur. Now, Georgia asked, what about the other way? If I combine something from up here with down here, so for example, just say I had some silver metal and I set it in a solution of copper sulfate. Nothing happens. That's what happens if you get them around the other way. Okay? So this one is a spontaneous redox. And the other way is no reaction. Okay? Now, often I get to this stage and I say, is everyone happy? And everyone says yes. And then we go to do the first question and everyone gets stuck on the first question. So what I want to do is talk to you a bit more about what to do next. So if you look on page 16, right, a piece of copper is placed in a solution of silver nitrate. A layer of silver crystals form on the copper surface, and after a while the solution turns blue, indicating the presence of copper 2+ ions. So the reaction equation is the copper plus the silver nitrate forming the copper nitrate and there's a 2 missing from the in your booklets there. Actually it's not, no, it's not balanced, is it? Because we need two silvers as well. So the whole equation is not balanced. Now the thing to remember is we're really more interested in ionic equations. And so the nitrate ion is a spectator. And I can look at this on my electrochemical series and I can see, well, do I predict that this reaction would occur anyway? I've got copper metal and I've got silver ions. And so they are in that diagonal relationship with a stronger oxidizer reacting with a stronger reducer. And so yes, I do anticipate a spontaneous reaction to occur, and I can just write them down as they're written on there. So I've got my silver, and I've got my copper. Now that's reduction. When I'm writing out the reaction for the copper, forming the copper ions, that's oxidation. So I don't just copy it directly off as it's written. I have to swap it around so that I'm writing the oxidation half equation. Keep the arrows lined up. And we can balance with our electrons like we've looked at before. So I've got 2 electrons here and I've only got 1 electron there. means I must multiply this by 2 to balance, to come together for a full redox. Okay. So, yeah, the whole, that example there, they don't have there's a 2 missing off the last silver in that example there too. So don't worry about the spectator ions for our solutions. So just say it says copper sulfate solution. What that means is that you've got copper ions. Okay, the sulfate doesn't matter. Just like it didn't matter that it was a nitrate here. Yeah? Okay, so don't worry about that. There needs to be something. There has to be an ionic compound of some description. But we're not, as long as a precipitation reaction is not going to occur, then what we're really interested in is, will a spontaneous redox reaction occur? Yeah? Okay, so anything with that, in this orientation, spontaneous redox, anything the other way, no reaction. Any questions?
In the exam, you have to state whether or not it's a spontaneous equation, like when you're answering the question.
You're probably more likely to, it might have, say, three reactions in a test probably. And are these, will a spontaneous redox reaction occur? If yes, then write out the equation, the half equations and the full equation. Is probably more likely what you're going to be doing, rather than stating that it will occur. But you could, I mean, that definitely could be asked. And I'm sort of stressing the spontaneous part because we need to keep all this in our head for later on when things get a little bit more complex.
So presumably if you're putting energy in, it might change it. It might
Absolutely.
be able to go the other way.
Yep, you hit the nail on the head there.
Mm.
All right, so any other questions? No? Right, so it's time to continue on then with your equations, with the questions. There's questions 15, 16 and 17 on page 17, as well as any that you might not have completed up to that point.